Hello, welcome to helpyourmath.com. This video is about scientific notation, multiplication, and division. Multiplying. The general format for multiplication is as follows: n times n to the x times m times n to the y is equal to n m times m to the x plus y. First, multiply the n and the m numbers together and express an answer. Secondly, multiply the exponential parts together by adding the exponents together. Example 1. Simplify 7 times 10 to the 8th power, all times 2 times 10 to the negative 5 power. Solution. We multiply 7 times 2 here, and then we multiply 10 to the 8th times 10 to the negative 5. So here we just do regular multiplication. 7 times 2 is 14. And here we bring down the 10 and we add the exponents. In this case, we get 14 times 10 to the 3rd. But the issue comes up that this is not in proper scientific notation. So we have to move the decimal point over one place. By moving the decimal point one place to the left, we add to the exponent a +1. If we want to look at this in terms of a number line, we start with 8, and then we subtract 5 to get 3. This is what happens with the exponent. And then because we have to move the decimal point, we end up with 4 in the exponent. In example number 2, we're going to multiply 3 times 10 to the 6th power, all times 4 times 10 to the negative 2 power. Solution, we multiply the m and the n, or what is equivalent to, so that's 3 times 4, and now we take the 10 to the 6th power and multiply that by 10 to the negative 2 power, and we get 12, and this is 6 minus 2 gives us 4, so that's 12 times 10 to the 4th, but this is not in scientific notation, so we have to put it into scientific notation by adding 1 over here and moving the decimal point one place to over here. And we get as our final answer 1.2 times 10 to the 5th. And if we were to look at what's going on with the exponents on a number line, we go to 6, and then minus 2, and then because we have to add 1 to the exponent here, we add 1 and we get 5. Example 3, we have 5 times 10 to the negative 8, all times 3 times 10 to the 2nd. In this example, we will put the answer in scientific and standard notation. Solution, so we have 5 times 3, the 5 from here and the 3 here, and then times 10 to the negative 8th power times 10 to the 2nd power, and we get that from here. Then we multiply 5 times 3 to get 15, and then we use our power rule to get 10 to the negative 6. But the issue comes up because we have 15 here, and this is not in proper scientific notation because 15 is greater than 10. So it turns out that 15 is equal to 1.5 times 10 to the 1st power. So that means we add 1 to the power, and we move our decimal place over, and we get 1.5 times 10 to the 1st power times 10 to the 6th power, and these two mean the same thing, and we end up with 1.5 times 10 to the negative fifth. And if we write this in standard notation, what we want to do is we want to move this decimal place over 5 spaces to the left to get 0.000015 in standard notation. Dividing. The general format for dividing is as follows: n times 10 to the x power divided by m times 10 to the y power. So we have n divided by m times 10x minus y. First, we divide the n number by the m number and express as an answer. And secondly, we divide the exponential parts by subtracting the exponents from the exponent in the upper number. Example number 4. Divide 6 times 10 to the 6th power divided by 2 times 10 to the negative 2 power. Solution. So we put this in form, and we have 6 divided by 2 times 10 to the 6th divided by 10 to the negative 2. And since 2 goes into 6 3 times, and then times 10 to the 6th, and because this is division, it's the exponent is 6 minus 2 is equal to 3 times 10 to the 6th plus 2, since a minus times a minus is a positive. And that means our final answer here is 3 times 10 to the 8th. In example number 5, we're asked to simplify 2 times 10 to the negative 9th power divided by 8.1 times 10 to the 8th power. The solution is where we take the 2 and divide it by the 8, and we multiply by 10 to the negative 9th divided by 10 to the 8th. And since this is division, that means we're going to subtract. So we end up with 0.25 times 10 to the minus 9 minus 8. Now the issue again comes up that this is not in proper form because this is 0.25 and this is not greater than or equal to 1. So we have to move the decimal point over. And that means we're going to subtract 1 from the exponent and move our decimal point over to get 2.5 times 10 to the negative 18. In example number 6, we're going to divide 9 times 10 to the 9th divided by 3 times 10 to the 5th. And our solution is, as before, we split up the division problem into 2 separate division problems. The one with the numbers here and the other part with the exponents here. So we have 9 over 3 times 10 to the 9th divided by 10 to the 5th. So we have 3, because 3 goes into 9 3 times, and then 9 minus 5 will give us 10 to the 4th. And if we put that into standard notation, that will be 1, 2, 3, 4, or 30,000. In example number 7, we're going to look at a real problem. So here, if the speed of light is 3.00 times 10 to the 8th meters per second, how far would a beam of light travel in 3,000 seconds? Well, distance is equal to speed times time. We substitute in 3.00 times 10 to the 8th meters per second for our speed, and 3.00 times 10 to the 3rd seconds for our time, since 3,000 seconds is 3.00 times 10 to the 3rd seconds in scientific notation. So now we have distance is equal to 3.00 times 10 to the 8th power meters per second times 3.00 times 10 to the 3rd seconds. Note that the seconds cancel out, and we get that the beam of light would travel at 3 times 3 is 9.0, and then times 10 to the 11th, because 8 plus 3 is equal to 11, so it would travel at 9.0 times 10 to the 11th meters. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.